All right, so how do we find the sample size to be within a certain margin of error when we're dealing with the proportion? So this is from the Think Do textbook, question number 6. And let's see here. So we need to find, let's see. Part D says we want to get a better than, well, actually, before I go there, let's go back and work through this. So the point estimate for the adult proportion of all adults with pinworms is p hat. It's a proportion. And we got 72 out of 800 that had a case of pinworms. So I'm going to grab my calculator, my graphing calculator here, if I can do that. Here we go. And if I take 72 and divide that by 800, that's going to give me about 9%. So so my point estimate for the proportion of all adults with pinworms is 9% or 0.09. Remember, that's just based on this one sample of 800 people. Probably won't be exactly 9% or 0.09. So that's why we need to do the confidence interval work, and that's not what this video is about. So I'm not gonna do that, but I am gonna do part D, and I needed to know that proportion, that sample proportion, to come up with the estimate. Now, these are two little shortcut formulas that Dr. Stevens gives us in the textbook. And when it says p hat's known, that means you're going to use that 9% figure that we just calculated to come up with a little better estimate. And then they're going to say, well, what if you don't know? What if you haven't done a sample yet? How big a sample do you need to be within a certain margin of error? So since we know for part A or part D, they want us to use that prior estimate, and we know p hat was 9%. Let's see, it was about what, 0.09. So, and we know, let's see, for a 99% level of confidence, we need to use a 2.575 z-score. So I'm just going to start doing this calculation. So the z-score is 2.575. And that's going to get multiplied by my 0.09 number. And then remember, the Q hat's 1 minus that. So let's see, what's 1 minus 9? What's 100 minus 9, or 1 minus 0.09? I think that's 0.91. And that all gets divided by the margin of error squared. Now, we're supposed to be within 1 percentage point, it says. So that's 0.01. 0.01, and then we're going to square it. And then let's get that calculator back up here. So 2.575 times 0.09 times 0.91. And since this calculator does follow order of operations, I'm just going to type in 0.01 squared. Now, what you might want to do to be safe is square that 0.01 first. Actually, I just noticed that I didn't write point here. Let's see, will it let me do that? It will. Now let's hit enter. So that's telling me I need number. Always got to round up because 2,108 isn't big enough. We got to go 2,109 will be what we'll want to, how big a sample we'll need in order to be within 1 percentage point. And hopefully that checks it with the answer in the back. So now for part 2, it says, what if p hat's not known? Well, where does this 0.25 come from? People ask me often. Well, if you don't know the sample proportion, or you don't have some guess of what the population proportion could be, you go with something that's the most vague, and that's 50% or 0.5. So if you were to do the same formula using 0.575 times 0.5 times 1 minus 0.5 all over the margin of error squared. If you multiply 0.5 times 0.5, you're going to get 0.25, and that's where Dr. Stevens got that from. Okay, so let's go ahead and do that calculation, and it should be a bigger margin of error. I mean, a bigger sample size, because when you get closer to either extreme, 0 or 1, you're going to have a smaller sample size. When you get right in the middle, that's the, well, let's see. You know what, I'm going to be very lazy. I don't know if you knew you could do this with a graphing calculator. If you have a TI calculator, there's a couple things you can do. You can do second enter, and it'll grab the last thing you entered in and change it, and I can just change my arrow back over. I can type in a 5 here. I could just type in 0.25, I guess. Let's see, 0, 5. You know what? I'm going to get a wrong answer, aren't I? Because I'm doing 0.05, not 0.5. See, I've been better off to type in 0.25. Okay, so that time, yep, that should do it. Notice how much bigger that is. I mean, 3 times the size. So 6438 would be the size of the sample. Okay, so that's why it's good to come out. What they'll do when they'll do a study and they don't have any idea what's going to happen, they'll go do a little mini study, a little preliminary study. You know, for that matter, I hate to say this, but a convenience sample would give you a better result. To do it right, you'd want to do a random sample. But so hopefully this will help you figure out how to do the problems on the problem set.